Evaluate the definite integral using integration by parts. The lower bound is 1, the upper bound is 2, and the function is parentheses the natural log of x squared dx. Okay, so in our problem, we're going to let u equal the natural log of x squared, and dv is going to equal dx. Okay, now when we take the derivative with respect to both sides, the derivative of the natural log of x squared is the following. We have the derivative, which is 2 times the natural log of x times the derivative of what's inside, which is 1 over x. So therefore, du is going to equal 2 over x times the natural log of x dx. And then v is going to equal x when we take the antiderivative of 1. Now for step 3, write our original problem. We have that integral, and then we're going to use the following formula. U times v going from 1 to 2 minus the integral going from 1 to 2 v du. So we know that x is the natural log of x squared, and v is x, minus the integral going from 1 to 2 of v, which is x times du, which is 2 over x times the natural log of x, and that's dx. So let's do a little bit of simplification before we proceed. So we have x times the natural log of x squared. Now that is going from 1 to 2 minus, well, this x divided by that x is going to be 1, and we can factor out the 2. And so going from 1 to 2, we want to take the antiderivative of the natural log of x. So we can't use substitution here, so we're going to have to do integration by parts again. So let's go ahead and do that. So by integration by parts, we're going to have to do the integration by parts for that integral. So for this integral here, we're going to go ahead and do that. So we have the natural log of x dx. Okay, and so then we're going to let u, capital U, equal the natural log of x. And then we're going to let d capital V equal dx. And so therefore, d capital U is going to equal 1 over x dx. And then v is going to equal x. And so now we're going to go ahead and then use our formula. So we have uv minus v du. So we know that u and v is x times the natural log of x minus v du, which is x times 1 over x du. Well, x times the natural log of x minus, well, x divided by x is just 1. And so what's the antiderivative of 1? Well, we get x times the natural log of x minus x. And therefore, that is the antiderivative. And so now we're going to evaluate it according to 1 and 2. Now we could have included that and then changed the u substitutions, but we can just find this using an indefinite wave with an indefinite integral and then substitute it back in according to x. So let's go ahead and do that. So we have, again, x times the natural log of x squared going from 1 to 2 minus 2 times we have x times the natural log of x minus x going from 1 to 2. Okay, so now we can distribute this 2, and so we have x times the natural log of x squared going from 1 to 2 minus distribute the 2 here. If we distribute the negative 2, we have x times the natural log of x going from 1 to 2. Negative 2 times a negative is going to give us positive 2, and then we're going to evaluate according to x going from 1 to 2. So let's go ahead and do that. So the first one, we have 2 times the natural log of 2 squared minus 1 times the natural log of 1 squared minus 2 times the natural log of 2 minus 1 times the natural log of 1 plus 2 times 2 minus 1. So we end up getting 2 times the natural log of 2 squared. We know the natural log of 1 is 0, so that's going to be minus 0. And then over here, we're going to distribute the negative 2. So we have minus 2 times 2, which is minus 4 times the natural log of 2. And then this is 0, so that's going to be plus 0. And then over here, this is going to be plus 2 times 2 minus 1, which is 2. And so therefore, here is our result. 2 times the natural log of 2 squared minus 4 times the natural log of 2 plus 2. And therefore, there is our result.